So a three-block system is shown accelerating to the right. So let's draw an accelerating arrow to the right here. A force F is acting on block 3, and there's no friction between any of the surfaces. Determine what value of F is needed to ensure that the block 2 does not slide relative to block 3. Assume that block 1 does not touch block 3. So what's happening is, see, if this thing wasn't accelerating to the right, and this block M1 was just hanging here, block M2 would accelerate to the right. That's what would happen. So what has to happen is someone is pushing on M3 to make it accelerate so it can keep up with the acceleration that M2 is feeling. Okay? So, like, you have to figure out what force is necessary to make those accelerations match. There's no friction, right, that's happening. So how do we kind of start with this? Is we kind of start with the free body diagram of everything, right? Now, where do you want to start with? I'm going to start with the free body diagram of M3 first, and talk about the forces acting on M3. So we have the force. So if I look at a free body diagram of M3, I have F moving to the right. I have gravity, M3G, going down, gravity of this block. Then I have M2 pushing down on it, right, M2G. And then I have some kind of normal force from the ground. I guess it's like a table it's sitting on or something like that, that's holding it up. Okay? So all you can see is the vertical forces cancel because the thing is not accelerating up and down. So what you can see is that, F, the net force, which equals MA, is F equals M3A. Okay, so I have to figure out what the acceleration is, right? Once I know the acceleration, then we're generally good. Okay. So now we want to look at a free body diagram of M2, okay? So if I look at M2 and I draw a free body diagram, I'd have M2G going down, and then I'd have a normal force from block 3 pushing up on it, and then I'd have a tension force going to the right, okay? So if I look at this guy, the net force equals MA. I only have tension in the horizontal direction, and that equals M2 times the same acceleration, because if I don't want M2 to and M3 to separate from each other, they both have to have the same acceleration. Okay? Now, how about M1? M1's got this interesting thing what's going on is like M1 is just hanging here. Like if they're all sliding to the right, there's no way M1 can fall. So if we look at the free body diagram of M1, we have to say like, well, I have M1G going down, and then somehow the tension is like kind of moving up this way, like this, at some angle. I can't, that you don't really know. Okay? So how can I find a component of the tension? Well, so if we want to break this down, we have to break this down into two components. There has to be a vertical tension force and a horizontal tension component of the tension force, like that. Right? So this is T1 in the y direction, this is T1 in the x direction, for example. I'm not given the angle, so I don't want to put it in terms of angles yet. And so if I look at this guy, the net force, now which way is M1 accelerating? He's also accelerating to the right. He's actually not falling downward at all. Okay, so the net force for this guy is going to be in the x direction. You'd have T1 x component. That equals M1 times A. And in the y direction, basically, it's not accelerating up and down because we're pushing the block enough so M2 kind of just sticks there. So M1 just only accelerates to the right and doesn't fall downward. And so we could say in the y direction, his T1y is equal to M1G. Okay? So that's kind of where we're at if you just look at the free body diagram of this situation here. Okay, so how do we connect tension to T1x and T1y? Well, you know that tension, this total tension here, is going to be equal to, tension is going to be equal to the square root of T1x squared plus T1y squared, right, by Pythagorean theorem. And so in this case, that's the square root of M1g squared plus M1a quantity squared. See that? Okay, because I know what those forces are, so I can figure that out. And then I can plug the tension into there. Remember, my goal is to figure out what the acceleration is, right? Because ultimately, what I need to do is I need to figure out what A is. So I need to get an expression in terms of A. So then I have the square root of M1g quantity squared plus m1a quantity squared is equal to m2a, right, from this equation here. Plugging that tension in there. If I square both sides, just to get rid of the square root, I'm going to have m1g quantity squared plus m1a quantity squared is equal to m2a quantity squared. And let's go ahead and square everything. So this is m1 squared g squared plus m1 squared a squared is equal to m2 squared a squared, right? So I just squared everything. And then I want to group all the a's together. So that means m1g squared, m1 squared g squared is equal to m2 squared a squared minus m1 squared a squared. I factor out an a squared, divide it out, and then I'll take the square root. So that means m1 squared g squared over m2 squared minus m1 squared is equal to a squared. Okay, and then a is then just the square root of this thing. Okay, you could take the square root of the top already, and that would just be m1g, and then you just have the square root of the bottom, m2 squared minus m1 squared. And so that's the acceleration, and so finally I can calculate the force. The force is m3a, and we've calculated what the acceleration is now. That's m3 m1g over the square root of m2 squared minus m1 squared. Okay.